Hello students, in today's lecture we are going to study a very important reaction, a reaction which goes by the name Baeyer-Villiger oxidation. So what exactly students is Baeyer-Villiger oxidation? Now in Baeyer-Villiger oxidation students, we introduce an oxygen atom in a aldehyde or a ketone. Now this oxygen atom is introduced from a per-carboxy acid. And students will understand the mechanism कि reaction होता कैसे है, and there's a very important concept of migratory behavior. We will try and understand that. So let's quickly jump into the reaction. Students, one more point, this reaction is widely used in the synthesis of lactones, which is synthesis of cyclic esters from cyclic ketones. So for example, we have taken acetophenol, and students, to do this reaction we need a per-carboxy acid. So let's take a per-carboxy acid. Students, one of the most widely used, though we can use any per-carboxy acid, एक और जो यूज होता है in this reaction is called as meta chloro carboxybenzoic acid. I repeat, meta chloro peroxybenzoic acid. हम ये भी यूज करते हैं in this reaction. So क्या होता है students? Oxygen is inserted. So यहाँ पे what we observe is फिनाइल रिंग के बाद एक ऑक्सीजन इंसर्ट हुआ है इन द रिएक्शन. And along with that we have carboxylic acid. So students, what we need to really understand in the reaction is why is an oxygen inserted next to the phenyl group. CH3 के बाद ये क्यों नहीं हुआ, ये हम समझते हैं in the migratory behavior. So let us first understand students the mechanism of the reaction. How does this reaction actually take place? तो इसकी mechanism समझने की कोशिश करते हैं. Now we first need an acid to protonate the carbonyl oxygen. तो ये हमारा कार्बोनिल ऑक्सीजन है. टू प्रोटोनेट द कार्बोनिल ऑक्सीजन, लेट्स से हमारे पास वी हैव एन एसिड. सो दिस प्रोटोनेट्स द कार्बोनिल ऑक्सीजन. ठीक है, दिस विल बी यूज्ड लेटर. एंड नाउ क्या होता है, ड्यूरिंग रेजोनेंस. सो यहाँ पे जो आपका कार्बोनिल कार्बन था, दैट कार्बोनिल कार्बन विल नाउ डेवलप अ पॉजिटिव चार्ज. CH3. Now in the next step students, what happens is, अब आता है हमारा पेरोक्सी एसिड, पर कार्बोक्सी एसिड. सो दिस इज आवर पर कार्बोक्सी एसिड स्टूडेंट. ये है हमारा कार्बोनिल कार्बन. So let's understand. Now next what happens is, so we have the protonated carbonyl oxygen यहाँ पे था. And then this oxygen is now वो आपके कार्बोनिल कार्बन पे बॉन्डेड है, this oxygen. दो लोन पेयर थे, now it has one because ये one of the lone pair is now present bonded to the oxygen carbonyl, pardon me, that is here. And now students, this comes into picture, which will extract, the base will extract proton. These electrons go back to oxygen as lone pairs. And now students, the acid protonates the oxygen of the percarboxy acid. And यहाँ पे students इस step के बाद you're going to have a very important migration यह हो गया आपका ऑक्सीजन प्रोटोनेट. And now students, here comes the important step. Now the phenyl group will migrate and ये electrons जाते हैं as lone pair. This is the most important step of the mechanism students. ये step आपको एकदम ध्यान से समझना है. And you also need to realize कि migratory behavior is very important. If we look at migratory behavior, the migratory behavior follows this trend students. ये भी आप ध्यान में रखना. Tertiary alkyl, then comes secondary alkyl, and then we have primary alkyl. This will be the migratory behavior depending upon the group which is attached. ये migratory behavior पे I will also give you some examples to practice. And so students, finally यहाँ पे we have if you see students, phenyl group migratory okay, oxygen भी यहाँ पे attach हो गया है, and along with that we have RCOOH. तो हमें हमारा ये प्रोडक्ट तो मिल गया. And now students, what happens here is, if you see carbonyl carbon पे there is a positive charge, positive charge on the oxygen, and then again the base will come back to extract its proton and we get the final product. हमें हमारा ester मिल गया. We get back our phenyl ethanoate. So students, this is the detailed mechanism. I repeat, migratory behavior is very important. So remember migratory behavior, because students, on the basis of migratory behavior you can then try to solve these questions. I'll help you with one example. So जैसे कि if I observe over here, ये हमारा tertiary group है, so the migratory behavior prefers the tertiary group, so the product here will look like this. आपका oxygen atom will be inserted over here. Similarly students, this is cyclohexanone. Cyclohexanone student gives us this product. And many students, if you remember this is caprolactam. Students, caprolactam is used in the preparation of nylon 6. Students who have studied polymer will get this. And the third question, students, try to do this as homework. And this is your migratory. यहाँ पे इसका migration होगा and oxygen will be inserted in between. So I hope students, this short quick session on Baeyer-Villiger oxidation, I hope आपको सबको अच्छे से समझा हो. If you have any doubts or any questions regarding this, I would please request to share your questions in the comments. If you liked the video, please share and subscribe. Thank you so much.